Hello everyone, welcome to the lecture series on Fourier series. For more videos, please like the video and subscribe channel and click the bell icon. First, let's discuss the definition of Fourier series. The Fourier series for the function fx in the interval x is greater than 0 and less than 2 is given by fx equals to a0 over 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. What are the a0, an and bn? The a0 equals to 1 over 5 0 to 2 pi integral of fx dx, and also an equals to 1 over 5 0 to 2 pi integral of fx cos nx dx, and also bn equals to 1 over 5 0 to 2 pi integral of fx sin nx dx, and also a0, an and bn are called as Fourier coefficients. Now let's discuss some examples on Fourier series. This is my questions and examples in here. Find the Fourier series of the first one is fx equals to x, the second one is fx equals to x plus x squared, and so on. Right, now here we go. Before move to the examples, let's discuss some tricks to solve the problems. My first trick is sketch the graph for given function. Also it is optional one. The second one is check whether the given functions are either odd or even or another. Third one is use special integration techniques to solve the problem. What are the odd functions and even functions? If f of minus x equals to minus fx, then fx is an odd function. And also fx equals to f of minus x, then fx is an even function. Here are some examples for odd function and even function. And also when the function is odd, the an equals to 0, and the function is even, the bn equals to 0. That is the major benefit of this case. Here are some special integration techniques for solving equations. You can refer these your own and get final answers easily. Let's do some examples on Fourier series. Find the Fourier series of following periodic functions. These are my examples, and let's begin with the first one, which is fx equals to x for x is greater than 0 and less than 2 pi. Solution of example number 1, which is fx equal to x, x is greater than 0 and less than 2 pi. In here I do this example by 3 steps. First one is sketch the graph, and second one is even or odd or another about the function, and third one is find a0, an and bn. The graph of the fx equal to x for x is greater than 0 and less than 2 pi will be like this. After looking this graph, we can get an idea about even, odd or another. This is another function. This is not an even or odd. The third step is find a0, an and bn. a0 equals to 1 over 5 0 to 2 pi integral of fx dx. Then we have to substitute fx as x. That is equal to 1 over 5 0 to 2 pi integral of x dx. After simplify this equation, we can get the final answer as a0 is 2 pi. Then we have to find an. An is equal to 1 over 5 0 to 2 pi integral of fx cos nx dx. After substitute fx as x, 1 over 5 0 to 2 integral x cos nx dx. After simplify this equation, we can get the final answer as an equals to 0. Now bn equals to 1 over 5 0 to 2 integral of fx sin nx dx. After substitute x as the fx and simplify the equation, and we can get the final answer as minus 2 divided by n as the bn. Now we have to write the equation for Fourier series of fx, which is fx equal to x. For this equation, the an, a0, bn are these. After substitute these values for Fourier series, we can get the final answer as x equals to 5 minus 2 times sigma n equals to 1 to infinity sin nx over n. And this is the animation for example number 1, which is Fourier series of fx equal to x. Now example number 1 is done. Let's move to the example number 2, which is fx equal to x plus x squared for x is greater than minus 5 and less than plus 5, and deduce that 5 squared over 6 equals to 1 plus 1 over 2 to the power 2 plus 1 over 3 to the power 2 plus 1 over 4 to the power 2 plus so on so on so on. Solution for example number 2, which is fx equal to x plus x squared for x is greater than minus 5 and less than plus 5. Step 1, step 2, step 3. Also we used these 3 steps in previous question. The first step is sketch the graph, and second one is even odd or another about the function. The third one is find the a0, an and bn. The graph will be this, and this is not an even or odd function, this is another function. For finding a0, a and bn, the a0 is equal to 1 over 5 minus 5 to plus 5 integral of fx dx. After substitute the x plus x squared as the fx, we can get the final answer a0 equals to 2 times 5 squared over 3. An equals to 1 over 5 minus 5 to plus 5 integral of fx cos nx dx. After substitute the function, and we can get the final answer an equals to 4 times minus 1 to the power n over n to the power 2. And also bn equals to 1 over 5 minus 5 to plus 5 integral of fx sin nx dx, and we can get the final answer as bn equals to 2 times minus 1 to the power n plus 1 over n. In previous question, we get the integral part 0 to 5, but in here we get the minus 5 to 5. It is our range of the x, and this is the time period of the x. Now we have to write the equation for Fourier series of fx equal to x plus x squared, which is x is greater than minus 5 and less than plus 5. These are the a0, an and bn values for this equation. After substitute these values for the general equation of Fourier series, and we can get the final answer as x plus x squared equals to 5 to the power 2 over 3 plus n equals to 1 to infinity sigma 4 times minus 1 to the power n over n squared times cos nx plus 2 times minus 1 to the power n plus 1 sin nx divided by n. This is the animation view for example number 2. Also, we have to reduce the solution as 5 squared over 6 equals to 1 plus 1 divided by 2 to the power 2 plus 1 over 3 to the power 2 plus 1 over 4 to the power 2 plus so on so on so on. For that, let's substitute x equal to 5 as the Fourier series of fx equals to x plus x squared. And we can get the final answer 5 plus 5 squared equals to 5 squared over 3 plus 4 times sigma n is equal to 1 to infinity 1 over n squared. And we can simplify that equation as 5 plus 5 squared equals to 5 squared over 3 plus 4 times 1 over 1 to the power 2 plus 1 over 2 to the power 2, 1 over 3 to the power 2 plus 1 over 4 to the power 2 plus so on so on so on, and get that equation as equation number 1. Similarly, let x equal to minus 5 and get the final answer as minus 5 plus 5 squared equals to 5 squared over 3 plus 4 times 1 over 1 to the power 2 plus 1 over 2 to the power 2 plus 1 over 3 to the power 2 plus 1 over 4 to the power 2 plus so on so on so on, and get the equation as equation number 2. Let's add the equations, equation number 1 plus equation number 2, and we can get the equation as, after simplify this equation, 5 squared over 6 equals to 1 plus 1 over 2 to the power 2 plus 1 over 3 to the power 2 plus 1 over 4 to the power 2 plus so on so on so on. This is our final answer. Now example number 1 and example number 2 are done. Let's move to the example number 3. Solution for example number 3. These are my 3 steps. First one is sketch the graph. Second one is even or odd or another function, which is about the function. And third one is find a0, an and bn. The graph will be like this. Also, this is an odd function. a0 equals to 1 over 5, 0 to 2 5 integral of fx dx. After substitute the equation for this equation, we have to divide it 2 parts for this question, because the fx function value will be 1 for 0 to 5 range of x, and fx value is equals to minus 1 for x is greater than 5 and less than 2 5. After simplify the a0 equation, we can get the a0 equals to 0. Also, we can tell simply a0 equals 0. How? Because the area of the function with the x-axis for one time period will be 0. Also, a0 is equals 0 and also an equals 0. Why? This is an odd function. Now bn equals to 1 over 5, 0 to 2 5 integral of fx sin nx dx. After substitute the equation fx to this equation, we can get the final answer as bn equals to 4 over n5 when n is odd and bn equals 0 when n is even. Now we have to write the Fourier series equation for fx equals to this function, and also a0, an and bn values are here. Now we have to substitute these values for the general function of Fourier series. After substituting these values for this equation, we can get final answer as 4 over 5 sigma n equals to 1 to infinity sine 2n minus 1 times x over 2n minus 1. How 2n minus 1 come? The bn value will be 4 over n5 when n is odd, and bn equals to 0 when n is even. For that reason we can directly write n as 2n minus 1 for all n values, which is n equals to 1, 2, 3, so on, so on, so on. By this method, we can get odd bn values only. And this is the animation view of example number 3. Now example number 1, 2, 3 are done. Now move to the example number 4. Solution for example number 4. Step 1 is create the graph. Step 2, even or odd or another function. Step number 3, find a0, an and bn. For your practice, I leave this question for you, and also I give the final answer for this question. Solution for example number 4 will be like this, and this is the animation view of example number 4. Thanks for watching. For more videos, please subscribe my channel and click the bell icon. Have a nice day.